Okay, so what we're going to do first as a warm-up is we're going to solve a trig equation. However, what we've been doing, solve this trig equation. Up until now, when we're solving trig equations, what we've been focused on is finding the answers between 0 and 2 pi on the unit circle. That means we are finding a finite or countable number of answers. This time, because this is going to be coming up in our near future, this time we're going to try something different and we're going to solve a trig equation, but instead of finding the answers between 0 and 2 pi, I want us to find all of the answers. That means I want every answer that is coterminal with the answers between 0 and 2 pi. And we have to write them in a special way. So I just want to give us a sneak peek of that because that's going to be coming up either later this week or next week in this unit. Solve this trig equation. Now, if the directions just say solve and they don't say between 0 and 2 pi or between 0 degrees and 360 degrees, if they don't tell you where to find your answers, that implies, it's implicit, all answers. It wants every single answer. In the beginning, they may be more explicit and they may just be like straight up with find all solutions. So I'm going to add that to be a little bit more explicit and in your face about it. Okay. Find all solutions. Now, if they ended at that, like right there, that would be up to you if you wanted to do degrees or radians, unless somewhere else on a worksheet or in a book, they indicated what they wanted. However, I'm going to indicate find all solutions, we'll make it a comma, such that, so now I'm going to give you a clue. Theta, the angle, is less, oh no, theta, I don't want to say it's less. I just said I'm going to find all answers such that theta is in radians. That's what I mean to write. Theta is in radians. We're not going to use degrees. Okay. So this is just tacked onto our instructions and we're going to solve. Now, solving equations. When you solved equations in algebra, you would maybe have like a linear equation like 2x plus 3 equals 0. You would subtract 3 from both sides. 2x equals negative 3. You would divide by 2 and you would get x equals negative 3 over 2. If you had something that wasn't linear, if you had something quadratic, for example, x squared plus 3x plus 2 equals 0. Well, to solve something like that, anytime your degree is bigger than being linear, what we needed to do is factor. I'm not going to go over how to factor. We did a lot of practice with that, and I will have a bunch of videos already posted, but I'll have factoring help videos in the description under this video, okay? But x plus 2 and x plus 1 equals 0, and then you used zero product property, which means you factored and then took each factor and set them each equal to 0. So if I went from there, I'm just squeezing this, I would end up with negative 2 and negative 1, and we got 2 answers. Or I'm just going to squeeze one last example. X squared minus 5x equals 0. So squash, sorry, that's a 0. Here, it doesn't look like this type of a quadratic, but you can still factor. And this is very similar to this, actually. We would take an x out front, factor out the GCF. We are left with an x minus 5 equals 0. And still like this one, we set each piece equal to 0. So what is that going to be? X set equal to 0 because that's a piece. And x minus 5 equals 0 because that's another piece. X equals 0 is one answer. X equals 5 is another answer. I know, super squashed on the side. All right. We're going to compare it to this old school algebra solving. Here, if I'm solving, I want to factor. This type of factoring, I'm going to pull out a greatest common factor. Anybody want to tell me what the greatest common factor is between this part and this part here? What's the biggest thing that they have in common? You could either type it in the chat, you could shout it out loud, or Sydney, you want to go for it?
Is it cosecant?
Yes. So cosecant theta is my greatest common factor. So I'm going to factor that out. Now, you don't end up with cosecant squared out front. You don't end up with 2 cosecant out front. When you distribute, everybody gets 1 because there's 1 out front. If there was a squared out front, then everyone gets an x squared. So just careful of that because people start bending the rules when they go the other way. Now, I showed this as like where I would underline with grouping, and we would write the GCF underneath, and I showed you the pretzel to reduce. So if you think of it that way, Ilsa, can you tell me what would be left on the inside over here?
Secant,
Good.
and square root of 2.
Good. Secant theta plus square root of 2. So now we're factored. It's very similar to that step x times x minus 5. Then what we're going to do is we're going to use essentially like the zero product property. We're going to set this piece of a product, a factor. Factors are the things that you multiply together to get a product. Product is the answer to a multiplication problem. Factor, factor, right? So we're going to essentially use zero product property. So in this case, I'll have cosecant theta equals 0, and it only works with 0. It's got to be equal to the happy 0. And I'm going to have secant theta plus root 2 is 0. Now, when does cosecant theta equal 0? That's one thing you're going to ask yourself. And you're going to have to figure that out for the unit circle. And then here, I'm going to subtract root 2, secant theta. When does secant theta equal negative root 2? What some of you might choose to do is you might think, I'm not as good with secant and cosecant as I am with sine and cosine. And if that's the case, fine. We can flip everything over, flip it all reciprocal wise, and change everything into sine and cosine. But if you flip the left side, you got to flip the right. So we're going to find the reciprocals of everything. So let's try that. What's the reciprocal of cosecant? Anybody want to go for that? What is the reciprocal of cosecant? You could shout it out. You could raise your hand. What is the reciprocal?
Sine.
Thank you, Jonah, right? Sine theta. Good. What's the reciprocal of 0?
Undefined.
Good. It's undefined. Undefined. All right. Justin, do you know what the reciprocal of secant is?
You said cosecant, cosine?
Well, this one. We're here. We just did this one.
Oh, thanks.
What's the reciprocal of secant now? We just did this one. So now we're doing this one. We're rewriting everything to sines and cosines to make it a little easier. Moreau, you want to help him?
Cosine?
Yes. And what's the reciprocal of negative radical 2? This is something I even asked you guys to work on memorizing much earlier in the school year when we were doing radicals. And I said, I promise this will all matter later. What's the reciprocal of negative square root 2? Anybody want to just shout it out? Anybody want to raise their hand?
Isn't it square 2 over 2?
Square root 2 over 2. Yes, but the negative stays. So just don't forget to lose that. I mean, lose that. Don't lose that. Don't forget to keep that. There we go. If I could speak. All right, there we go. Now, these might be a little easier to do. Where on the unit circle is cosine, which is the x value, right? Where on the unit circle, which angle, because that's what we're solving, we want to know what theta equals. There's going to be 2 answers for this. Where does theta, what angle theta, does cosine equal the negative square root of 2 over 2? The smallest thing cosine is, in terms of absolute value at least, is 0. The biggest it gets is to be 1. And then the numbers in between are 1 over 2, root 2 over 2, root 3 over 2. Root 2 over 2 is that medium amount, negative, and it's cosine. So it's left a medium amount on the circle. What angles does that go with? You will not have a circle handed out to you when we go back to school. So here's a circle. Cosine is x. Negative means left, so I'm going this way. And I'm going to find angles either here and here, this and this and this, or this to the left. And I want to know which angles, there's two of them. So if you could give me one and someone else will give me the other one, will cosine equal negative root 2 over 2 at? So you want to give me one of those angles, Mason?
3 pi over 4.
Perfect. And then do you know the other angle to go with that, Jahida?
5 pi over 4.
Perfect. Another clue that you're doing it correctly is they should be the same denominator if they came from the same problem, okay? Because they should have the same reference angle. Now, those would be the answers if I wanted just between 0 and 2 pi. Here's where they are. There's 3 pi over 4. There's 5 pi over 4. But I want all solutions. So I want not just the angle 3 pi over 4, which is right there, but I want every angle that lands there. So I can add on a full loop, or another full loop after that, or another, or another, or another, or I could have subtracted off a loop. One full revolution. How big is one full revolution? How big is one full revolution in radians? What size angle is one full revolution all the way around the circle using radians? Maybe Ben or Brandon. Oh, go ahead. Jasmine, you know?
Is it 2 pi?
Yeah. So if I add 2 pi, I'll get another answer and another answer and another answer. Now, the way we show, again, this is for the next lesson, just as a heads up, the warm up. The way you show that we can add 2 pi as many times as you want, 0 time, 1 time, 2 times, 3 times, or you could subtract it, is we write plus 2 pi n, but we have to say what n means. I'm going to put it here as well, plus 2 pi n here as well. And I'm going to put over here when n is an integer. Does anybody remember what an integer is? I feel like it's a scary word sometimes, where you're like, this sounds a little scientific. I don't know. I'm going to mess that up. What was an integer? Or you want to guess what an integer is? Probably didn't like beginning of algebra 1, beginning of algebra 2. Jonah, you think you remember what an integer is?
It's like the distance from 0, but like if it's negative, that is the distance from 0.
I think you're mixing up with absolute value, right? We say a negative became positive when it's an absolute value because you're saying how far it is from 0.
With the,
You cut out a little bit.
but wouldn't the integer of 5 be negative 5?
No, that's the opposite of 5 is negative 5. However, 5 and negative 5 are actually examples of integers. So I'm going to write this little curly bracket. I'm going to put dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, dot, 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 and then another curly bracket. So integers are just whole numbers, either positives or negatives. So it's like you could add 2 pi 0 times. You could add it once, twice, 3 times, 4 times. You can't add it half of a time because you won't go all the way around, okay? And we'll talk more about that later. Just wanted to kind of sprinkle it out there in this warm up so we kind of see it, and we're also warming up. So if you only went up to this part, okay, where we got those two answers and stopped there, that's what we're going to be doing today. In the next lesson, we're going to build on it and add 2 pi, and then sometimes we could add something different, and we're going to build on a different type of scenario. All right. So this is part of the answer. Now, one more part. When does either, you could think of it either way, when does cosecant theta equal 0? Or same idea, when is sine equal to being undefined? When is sine undefined? Anybody can figure out what angle between 0 and 2 pi that happens for? And if you can't, if you don't see it on the circle anywhere, let me know. When is the sine undefined? Maybe Jazz or Maddie, Matt, Ben, Brandon. Do you know when sine is equal to undefined on the unit circle? Do you see that anywhere? Max, Zayden, Samira, Shani, Oliver. You guys know? Can you see it?
I just heard you say my name. About what, Miss Thomas?
Max, we're having a lesson here.
I was paying attention. I heard you say math.
Yeah, I want to know, do you know when? So maybe Maddie, do you see anywhere on the unit circle that sine is undefined?
Is it like when it's at 90 degrees, the sine is undefined?
Well, I feel like that's where everybody wants to go look, right? Like where the zeros happen or, these extreme values. But what is sine of pi over 2 or sine of 90? What's the y value up there? Do you know what the y value is up there at pi over 2 at 90 degrees, Maddie?
No, I don't.
At the unit circle, remember it goes out 1 unit in each direction. So the y value of the ordered pair, if that's the origin, we go up 1 unit. So it's 0, 1. So sine is actually equal to 1 up there. So it's not undefined. So Matt, what do you think?
Isn't sine never undefined on the unit circle?
Exactly. Sine theta is never undefined. We always can get an answer. Go ahead.
Because it's just the y and x coordinates.
Well, sine is just the output, or the I don't want to say output. Sine is the y coordinate on the unit circle, yes, and it's never undefined. Like we can find the sine opposite of our hypotenuse for any angle because we could always make a right triangle. So this part you would actually have no solution. And this part is just sort of a throwaway. Okay, so this doesn't even matter. If it were reversed, if you got like sine is 0 or cosecant is undefined, that's different because sine is 0. Sine is 0 at 0. Sine is 0 at pi, but cosecant would be undefined there. But sine is never undefined. Again, today was just sort of to like sprinkle this out there, kind of expose us to this. So when we have our lesson next time, we've at least seen it. And we're going to do 6 examples today. They're going to go from 3 very easy ones and then 3 that involve a little bit more factoring and the trig identities, Pythagorean identities, and relate to what we've been practicing in our little transition lesson. So I hope that this kind of made sense. I know it might not be great the first time you do it with these like new symbols and when n is an integer. I promise it gets better. So eventually, if you end up rewatching this or watching it for the first time, if you understand a bit, decent, thumbs up on the video. But if you don't, if you're confused and you're like, SOS, I need help with this, put a thumbs down and I will make sure you get enough help on these. Okay.